just need to do this. Okay. I just need to take a couple of things out here. Okay, so today we're going to talk about chemistry and the periodic table. Just before we begin, I kind of want to go through the history of the atom. So this is very messy. Okay, so the atom. What does this word mean? This word means uncuttable, cannot be cut. So this is the smallest unit of anything in our world. So you take an apple, very poorly drawn apple, an apple, and you cut it in half, and then you cut it in half again, and then you cut it in half again. You are going to eventually end up with an atom, and the atom has a nucleus. Is there a pen tool that I can use to write a little bit neater? It's just a little, I'm using it now, but it's hard. Is there a way to use the pen?
You use this, you just get the mouse out.
Okay.
Don't click, it's already stopped working.
Okay.
See? 1, 2, here. I'm not left-handed.
Okay.
This is 1, see, 2.
Perfect. Okay, that's much better. Just don't click.
Don't click.
Got it. Okay. So.
Oh, you need to.
Oh, now I go back to this?
Yeah.
Okay, got it. To clear this and then go back to this. Okay. Sorry, I'm just getting used to this system. So, you have an atom.
Oh, you gotta click on the power button.
Okay.
There you go. Stop writing.
Okay. I have a... Oh.
You gotta use one device at a time.
Okay, so then using this, click on this,
Yeah.
take this off,
Yes.
and now it's coming over here.
Oh, just, there you go.
I have to start all the way over here, I guess. Okay, so you have an atom, has a nucleus. It's made up of protons, neutrons. Protons have a positive charge. Neutrons are neutral. They have no charge. Now, generally, we have the nucleus, protons and neutrons, and then we have things that are surrounding the nucleus called electrons. This is the symbol for the electron. Okay? And this is basically the structure of the atom. You have the positive charge in the middle and the negative charge on the outside. If you take another atom, nucleus, thank you. and its surrounding electron. What's all this in between the electron and the nucleus? It's nothing. It's space. Nothing. This is nothing. In here, here, here. So what we consider your body, the apple, is mostly space. So I just want you guys to understand this is what we're talking about when we talk about elements. And the periodic table looks like this. This is Dmitry Mendeleev. He's a Russian guy. He really hates the barber, as you can see. He's pretty much never gotten a haircut or a beard trim, it looks like. But he's a very brilliant scientist, and just to give you history of Dmitry Mendeleev, he is given credit for formulating the periodic table, and he's the first person to design this system. And I know this looks really scary, but hopefully by the end we'll understand a lot more about the periodic table. When you break it down, it's very, very simple. Let's just go on to the next here. What is the periodic table? So this is the periodic table. It shows us every element on Earth. Every thing that's on Earth is made up of one or more of each of these elements. The organization. You can see these numbers here, 1, 2, 3, 4, 5, 6, 7, 8. These elements are organized in a very specific way. This isn't just randomly here, randomly argon is not just here because it's cool. This is very specific, and we'll talk more about this. How do you read the periodic table? So I have a better picture actually of the periodic table. So you have the periodic table, and each square on the periodic table has this number, which is called the atomic number, the symbol, the name, this in this case is carbon, and this is the atomic weight. Okay, so as I said before, let me just do the little super simple drawing here. Okay, so the atomic number for carbon is 6. The name, obviously, is carbon, and the weight is 12. So the electrons that are circling the nucleus are very, very, very small. So small that when we're talking about the periodic table, we don't take them into account as weighing anything. This is, for us, equal to 0, the weight 0. Carbon just happens to have 6 electrons and 6 protons. Okay, and it also has 6 neutrons. Okay, so electrons, protons, neutrons. protons and neutrons are in the nucleus. The electrons are surrounding the nucleus. This is all empty space. So so you may be asking, you have 6, 6, and 6. This is 18. What does this mean? The weight is the protons plus the neutrons. 6 plus 6 is 12. You have electrons. They weigh almost nothing, so we don't even count them. The electrons are going to be equal to the protons. Plus and minus. Electrons to me the same number, but because these weigh nothing, this would be 12. So you can also know from this number, the atomic number, which is the most important part of this. Atomic number. This tells us the number of electrons or the number of protons. Okay, and we'll come back to this, so by the end maybe it'll be more clear. Number of protons found in the atom nucleus is the atomic number. So this is the protons or the number of electrons surrounding the nucleus. Or okay? Atomic number, most important number. Some periodic tables only give you the atomic number. The symbol. Well, this is pretty simple. The symbol is the abbreviation of the element name. In this case, carbon. And it's helpful because if we were to write carbon in huge letters, the periodic table would be enormous. So, yeah, these are going to become very familiar by the end of the year or the end of the term. Carbon is one of the most common, so there's only one, C, carbon. Move on here. The atomic weight, so number of protons and neutrons in the nucleus of an atom. So protons plus neutrons. Okay, so in this case, carbon, as we talked about before, has 6 protons and 6 neutrons. Here we know the number of, yep, that's right, protons and electrons. I should say or. Yeah, nice. I see it. Good job. Okay. So from this number, even if we didn't have this number, even if we couldn't see this, we know that there's the same number of protons and neutrons in the nucleus. So you have 6 protons. That means you're going to have 6 neutrons. When you look at your weight's going to be 12. So we'll see this more clearly. How do I find the number of protons? Yes, very smart. Okay, perfect answer. Yeah, I'm not sure if I'm going too slow or too fast, but hopefully you understand some of this. It's a lot of information, and you can revisit the slides, I think. I don't know. Okay, so yeah, just download the slides and go back over this if it's confusing. This is a very important page. You're going to want to really know this. It's basically exactly what we've been saying. The number of protons is the atomic number. Number of electrons is also the atomic number. This is the 6 in carbon. Okay, 6 carbon 12. Okay, so atomic number is this. Okay, so from the atomic number we can find out what the atomic weight is. The atomic weight is the protons plus the neutrons. So to find the number of neutrons, we just take the atomic weight minus the atomic number. So in this case it would be very easy. 12 minus 6 equals 6 neutrons. Pretty straightforward. So okay, we know there's 6 electrons, there's 6 protons, so there's atomic weight of 12. That means there are 6 neutrons. Yeah, so yeah, he's not a looker, but he's a very, very brilliant scientist. Dmitry Mendeleev, 1902. So this is kind of the part of the periodic table we're going to be working with. This stuff down here kind of follows the same rules, but they're just very, very large. You can find out pretty much how the periodic table works based on this upper part. These are the most common used. You're going to hear these names a lot. If you, which I'm sure you will, all become famous chemists. So what is an element? An element is simply a substance composed of a single kind of atom. So this could be hydrogen or helium or potassium. Okay, that could be any of those, any of these elements, right? Each one of these is an element. If this is by itself, lithium, sodium, potassium, helium, krypton, carbon, nitrogen, oxygen, all of these are elements. Okay? Notice that these are just one kind. They're all red. Okay? So let's just call this red guy hydrogen. So say you have a bunch of hydrogen gas, which by the way is extremely flammable. It will explode if you light it on fire. We'll just call these hydrogens. This is an element, and it's in its elemental form. Okay, and just so you know, it's a gas. Can't be broken down into another substance by chemical or physical means. So these are atoms, and like we said at the beginning, they're the smallest form on Earth. So for our particular needs, this is going to be the smallest form on Earth, and which means they can't be broken down into another substance. What's this? What's going on here with this? This is a yellow ball attached to another yellow ball. So these are each elements. Let's call this oxygen. Big O. Oxygen, as we see it, what we breathe in to our lungs is O2. O2. And what's this little 2? Can anyone tell me what this little 2 is? O2. Well, it just means 2 oxygen molecules, 2 atoms. Okay? Yes, perfect, thank you. 2 atoms, and they're connected. And this is how we typically see oxygen. It likes to be connected to another oxygen. Is this an element? If I were to draw a circle here, would this be an element? Can anyone tell me? Would this be an element? Yes, it would be an element. This is all oxygen. These are all O2. This is a single kind of atom, oxygen. Okay, what is a compound? So this compound here is very, very important. It's very simple. It's the only reason we're alive today. Let's call this water. H2O. Okay, so now we have the hydrogens. This guy's, we're going to call this hydrogen, and we're going to call this guy oxygen. Okay, okay. Maybe this microphone. No, it's good. It feels good. Okay, sorry. I'll try to speak louder. So this is hydrogen, and this is oxygen. So H2O, there are 2 hydrogens and 1 oxygen, and we call this a compound. And we can go into as much detail as you want later about why these interact, why they're connected. But for now, let's just focus on what is a compound. So we have hydrogen, which is one element, and oxygen, which is another element. And when these two are bonded together, which we use this line to show that they're bonded together, this means that they form a compound. And you'll see in the diagrams these will be different colors, and you'll be able to recognize a compound by this connected line here, which means that they share electrons, but we'll get more into that later. Okay, what is a mixture? So say this is in a container, and we have, let's say, this is helium, okay, and this is, I don't know, xenon, okay, helium is red, xenon is blue. So if you just filled up a bottle, okay, you have a little glass bottle, and you fill it with with these. In nature, helium and xenon don't want to make a bond here. They don't like each other. This is because of their properties, which we'll talk about later. But if you were to put them both into a bottle, they would not bond. But there would still be these 2 elements in the bottle not chemically bonded. Not chemically bonded. And we call this a mixture. So just to go back and review, we have an element, which is a substance composed of a single kind of atom. So you have a bottle of hydrogen, you have a bottle of oxygen, you have a compound, which is a bonded chemically substance where there are 2 or more elements, different elements, H2O, compound. And we have a mixture, which is 2 or more substances that are mixed together but are not chemically bonded. Alright. So again, if you are confused, just review the slides. Also, I have you can send me questions on my email. If you have questions, please send me on my email specific questions about the lecture. Okay, so just going over this again. Is this an element, a compound, or a mixture? Here we have one element, and we have another element. Yes, mixture, perfect. Can everyone see this? There are no bonds, there's no lines between these two. They're not bonded, but they are in the same place. Say this is bottle, you know, or whatever you want. Element, compound, or mixture. Man, super fast. Perfect. Yes, this is a compound. You have the line connecting the two elements. Most of you got that right. Two elements shown by the two colors connected with a line. This one's kind of tough. Element, compound, or mixture. Well, yeah, it is a mixture. So you have this compound here, and you have this element here. This is a substance. This compound is a substance, and this is a substance. So we can go back to two or more substances that are not bonded. So perfect, you all got it. Mixture. This one's pretty easy, hopefully. Boom, 100%. Okay, perfect. Element, correct. This is one element. Element, compound, or mixture. So we have a kind of a split answers here. This is a substance, and this is a substance. Two or more substances. Yes, it is a mixture. This, by itself, would be a compound. Because it's mixed with this other substance, it is a mixture. This looks just like, O2. We talked about it first. Ooh. Okay, so let's go back. Let's go back here. What is an element? A substance composed of a single kind of atom. Yes, it is an element. So even if there's a bond here, if it's the same element, this is just one element. Oxygen. It's just bonded to each other. Element, perfect. Element, okay. You're still not as handsome as the great Mendeleev. I am working this beard. Man, I look good. Yeah, this guy is very impressive beard. One of the best I've seen in quite some time. So it seems like you guys are getting this pretty easily. We're going to move on here to talk about the different parts of the periodic table. So this is just a blown up version of the periodic table, and this is pretty fascinating stuff. Each small square on the periodic table shows the name of one element and the letter symbol for the element. So this is can anyone, okay, so we have carbon over here. And does anyone remember what the 6 means in carbon? When we talked about it before, we had 6 carbon 12. Yeah, okay. So yeah, this is the atomic number. So this says it shows the name, but it actually doesn't show the name. This says it just shows the symbol and the atomic number. So this is carbon, and it has an atomic number of 6. And 6, what does this mean? Atomic number, what does this mean? You know, we talked about it a little bit before. It means the number of protons and the number of electrons. Okay, so this 12, the atomic weight, they don't even show it on this because it's not as important as the atomic number. Yes, perfect. So hydrogen over here is 1, meaning it has 1 proton and 1 electron. Aluminum over here has 13. Okay, so it has 13 electrons and 13 protons. And as you can see, we go all the way to 110. So this guy has 110 protons and 110 electrons. Pretty huge. Okay, so this chart is much more detailed than the last one. You may be asking, why is hydrogen floating in the middle of nowhere? It's over here, but it's here. And the reason is because this is separated into metals, metallic elements, which, as you can see, is most of these elements. Everything here, you know, sorry, except, let's see, everything, you know, these are all metals, okay, except for mercury, which is a liquid, and we can discuss that later. But and you have metalloids or semi-metals in yellow, and this just means that they kind of act like metals, but they're not really good at being metals. So we'll talk about what it means to be a metal a little bit later, but these guys are kind of in their own group because they're not very good at being metals. And then the rest of these are non-metals, and they're separated between, there's some of them are solids. You have some of them, where is that thing? There are solids. You know, bromine is liquid, and then you have these guys are gases. Okay, and these are the columns of the periodic table, 1 to 18, and then you have, whoop, what's going on there? 1 to 18, and then you have 1 through 7 are the rows. Okay, and we'll talk a little bit more about that. It says, please put to rest any fear you may have about needing to memorize the periodic table or even parts of it. Better to focus on the many great concepts behind how it's organized. So you don't have to, no one's going to give you a blank piece of paper and make you write this down. No one's going to say draw the periodic table. There's no use in that. But it is important to know the trends of the periodic table. So you need to know that these are metals, and there's a divider here. These are metals except for mercury. These are metalloids or semi-metals, and these are the non-metals. You will learn the names and symbols of the most common elements through the course of the class. If you choose to memorize them, it will help you. It will help you prepare for your writing formulas and balancing equations later. So these symbols represent names of the elements, and it sounds really hard, but it's pretty easy to memorize what these are. And if you choose to memorize the following 39 symbols, you'll earn a free homework pass. So the numbers are really easy, right? Because it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you know, they're going all the way down. And then you have slightly harder is to memorize the names. But if you make note cards or something like that, I promise it will take you maybe one day or a little longer to memorize it. So yeah, here are the ones that you should memorize. This is not all of them, obviously, but these are the ones that are common that we work with in chemistry all the time, and some of them can be confusing, like potassium has a K, whereas most of them are, you know, aluminum Al, argon Ar. So there's that. The vertical columns of the periodic table. Okay, vertical columns of the periodic table. These are groups. And why are these like this? This is so confusing. I have no idea. It's actually very simple. These over here are called the noble gases, which means that they are found alone. They are very rarely found with other elements, bonded. If you remember before, I said that it's kind of hard to see, but these are the noble gases over here. I don't know if you can see them, but I said that, you know, helium and xenon. Helium and xenon. They do not want to bond together. They don't want to have anything to do with each other. They're very happy being apart. So the noble gases, they like to be alone. Okay? So each of these columns represents similar characteristics. Fluorine, for example, really likes to take electrons. It likes to bond with other elements a lot. These guys over here, which is called the alkali metals. You don't need to know that, but this column over here, they really like to give away electrons, and these guys like to take electrons. But it's not important until a little bit later to know the details. Just know that these vertical columns, okay, the families, these vertical columns are called groups or families, and they basically show us the different chemical properties. They're grouped together. They're similar. The periods, which are the horizontal rows of elements in the periodic table. Physical and chemical properties change somewhat regularly across a period. So this is more complicated. These basically tell us that going from left to right, the element is getting bigger. So carbon is smaller than oxygen. So let's see, go like this. Okay, so they're getting bigger as they go to the right, and they're also getting bigger as they go down. So hydrogen, as you can guess, is the smallest element. Can anyone guess which is the biggest element? So the elements are getting larger as you go left to right, and also as you go top to bottom. So kind of in this direction. Yeah, here we go. Biggest element, smallest element. Okay. So the periodic table is broadly divided into two main sections, metals and non-metals. So like we said before, the metals are a huge group of the periodic table. Everything kind of from here over except Mercury is a metal, metallic element. What is a metal? Well, most are solid at room temperature. They're malleable, which means you can flatten them. Kind of, malleable is you can flatten them. Ductile means they can be stretched to make wire. And luster just means that they're shiny. So yeah, just know that they're most of the periodic table is made of metals, and that they are malleable, which means they can be flattened. Ductile, which means they can be stretched into wire, and they have luster, meaning that they are shiny typically. They reflect light. I don't have a time monitor on here. Do you know? I'm not sure if okay, yeah, thank you. Okay, so pretty straightforward, pretty easy. We don't need to know the details that much of the periodic table right now. Just introducing it, we know that these are the groups or families, these columns. Okay, we have the noble gases, alkali metals, and we need to know these horizontal units are the periods. Okay, and we know that as we go from left to right, the elements become larger. Non-metal, an element that is a poor conductor of heat and electricity. So say we have, a stove, it's got the flames, that's flames, in case anyone, I'm an artist, by the way, that's my profession. And then, we've got a substance we want to make hot up here. If this is just air, gas, it's not going to really conduct the heat. It's not going to transfer the heat to the object. A metal, like a pot, if you put this in the pot, it's going to heat this up. So we cook using metal usually because it conducts heat. Also, when you're listening to music on your headphones, what's connecting the music to your headphone from your iPod is metal. It's because it conducts electricity. It's able to conduct that thing well. So non-metals are blue. So these are poor conductors. Let's see if I can redo this. Okay, poor conductors. Metalloid is an element that has some characteristics of metals and some characteristics of non-metals. So that's basically saying it's not a non-metal, it's not a poor conductor, but it's not necessarily a good conductor either. And I've shown you guys that. It's this small group of yellow. So they're not very good conductors, but they're not horrible conductors. So this is, these are the poor conductors, and then these guys they're okay. They're all right. So they're called semi-metals or metalloids. So we spoke a little bit about this. Noble gases, the elements in group 18, are gases at room temperature and generally unreactive. So what does this mean? Unreactive. So we have helium is a noble gas. And unreactive just means if you were to put helium in a bottle with another noble gas, yeah, right, exactly, no compound. They do not form a compound. Thank you. They don't react with these other elements, and the reason is because they're very happy with the number of electrons they have. So helium has 2, and it really likes having 2. So this other electrons, fluorine for example, it wants to have another electron. Helium is fine with having its 2 electrons, is really happy with that. So they're gas and they don't react with other things. So when we find these in nature, they're always in their elemental form. They're not compounds. Very good. So yeah, just to review, we have these metallic elements on the left. It's most of the periodic table, obviously other than mercury. And mercury is still a metal, it's just a liquid metal. It's very cool, highly toxic, but it's interesting nonetheless. And so we have these 3 major groups. We have the semi-metals, the gases, and the metals. And we know that these are the groups, these columns are the groups, these rows are the periods, and the elements are getting larger as you go from left to right and from top to bottom. And finally, we know that the noble gases, which is just these on the right, and some people put helium in this category. Typically, no, it's over here, but some people put it right in the middle. This is a very strange element. We'll talk more about it, but this is the noble gases. And is there any questions about anything specific before we finish? Does anyone have anything specific they want to ask? No, sir. Okay. Well, hopefully you guys understand this. You have, element, mixture, compound. Again, just review these slides if they don't make sense, and feel free to send me questions on my email, because this can be confusing, but just try to memorize these symbols to get the free homework pass, and just try to remember these simple characteristics of the periodic table. Yeah. Yeah. So, goodbye. I'll see you next time. I don't know how to. Okay.
Yeah, but you need a passport. Passport? Yeah, you also need a real copy of your passport. No, I actually have. That's good. I'll see you here Monday.
Come in.
What time? English?
10 o'clock.
10 o'clock.
วันอังคารมีค่ะวันอังคาร
Oh, just coming on Tuesday.
On Tuesday?
Yeah.
Okay, cool. And that will be training and it'll be full time from there on out.
Yeah.
Groovy. Awesome, thank you.
Take it easy.
เอ้าก็มันหมดชั่วโมงแล้วนะหมดเวลาแล้วมีคำถามอะไรหรือเปล่าเดี๋ยวพี่เต้เข้ามาก็ได้ปิดกล้องกัน
So, Kurt.
What's up? You got another class about motion.
Yeah.
You alright?
I just have.
What's up?
I guess I was preparing for like a video. So I have like a whiteboard plan. So I know like it was kind of like a little difficult to do the whiteboard plan with the pen.
Yeah, I know, but the thing is, this is the system that we have to use for the live teaching to the kids. I mean, we wish we can do like a whole recording thing, but
Just a little bit. Yeah, no worries. I just wanted to.
Sorry.
No, it's fine. I noticed that they're talking.
oh,
And Thai a lot.
we have the TA upstairs to help.
Oh, okay. So
They the one who type the Thais to the kids, making sure they're listening to you and all that.
okay.
Yeah.
Okay.
I know it's a little distracting, but this is how we do it online, you know. So.
Yeah, no, that's fine.
Yeah.
So I just,
แป๊บนึงนะเดี๋ยวพี่เต้คุยด้วย
I just wanted to. Do you have a little time after the next lesson? We can
Yeah, of
talk
course.
a little bit.
Sure.
Just about where to go from here.
Okay, sure.
Cool.
อ่ะมีคำถามอะไรป่ะเมื่อกี้ฮัลโหลเดี๋ยวครูเคลวินเขาจะสอนนั้นต่อนะสอนวิทย์มหนึ่งสวัสดีครับสายลุงฮะน้องๆเห็นมีน้องๆจากสาระด้วยนี่คือพี่เต้นะครับพี่เป็นครูกับทิวเตอร์ภาคภาษาไทยของที่สมาร์ทเคอร์ติวรถanyway เมื่อกี้ครูเคลวินสอนไปแล้วมีคำถามอะไรบ้างไหมเพราะเดี๋ยวเราจะเริ่มวิชาวิทย์ของมหนึ่งมีไหม PowerPoint โหลดที่ไหนล่ะครับ PowerPoint เมื่อกี้ให้ลิงก์ไปแล้วนี่เดี๋ยวให้พี่ก้องเขา copy ลิงก์แล้วแปะลงไปแล้วกันให้เป็นแล้วนะลิงก์เดี๋ยวพี่ลองดูให้ตึ๊บฮึบเจอละแป๊บหนึ่งเดี๋ยวขอพี่ก๊อปชึบนั่นคือลิงก์ครับมีคำถามอะไรไหมวันนี้เรื่องตารางธาตุดูตารางธาตุแล้วมึนเลยสิมีเรียนพรุ่งนี้เหรอครับพรุ่งนี้วันเสาร์ใช่ไหมวันนี้วันศุกร์แล้วนี่โอ้เสาร์อาทิตย์พักเถอะนะครับเสาร์อาทิตย์ไม่มีนะแล้วก็นอนบ้างอะไรบ้างดูการ์ตูนบ้างดีไหมอีกอย่างหนึ่งวิดีโอเดี๋ยวของเมื่อวานนี้เดี๋ยวจะอัปโหลดไปให้นะครับสำหรับคนที่อยากดูรีรันมีรีรันให้ดูโอเคน้องๆม.2 ขอวังใครอยากไปพักผ่อนนะครับเดี๋ยวมีม.1 สวัสดีครับสวัสดีแต่ว่าเดี๋ยวมีสอนวิทย์ม.1 นะครับเรื่องโมชั่นโอเค